In today's mini lesson, we are going to be building our own plasma membrane to see how the transport of molecules happen across it, right? But before that, let's quickly jump into the structure of our lipid bilayer. So the lipid bilayer really has two major components. We see these hydrophilic heads. They love to interact with water. They can interact with water. So hence the word hydrophilic, water loving. These tails that you see that are making the interior of our lipid bilayer, they're largely hydrophobic. So they don't want to do anything with water, right? Now, the permeability of your substance really depends on the nature of that substance, whether we're dealing with something that is uncharged, polar, non-polar, or a charged species. Is it hydrophilic? Is it hydrophobic? So on and so forth. So let's see how the transport of molecules happens across plasma membrane. Now, if we pick oxygen, oxygen is uncharged, non-polar, so the plasma membrane is probably going to be like, oh, that's delicious. And as we can see, the oxygen can easily diffuse through the cell membrane because of its nature. It's uncharged, it's non-polar, so it can easily move through our largely non-polar lipid bilayer, right? Same goes for carbon dioxide, to be honest. Again, non-polar, overall no charge. So again, it can easily diffuse through the cell membrane. And this is how gases move across our plasma membrane because they have no charges on them and they're non-polar. But the same cannot be said for sodium. Now, the sodium ions have a positive charge on them, and that charge makes them hydrophilic. So as you can see that they can interact with the head really, but they're not passing through the largely hydrophobic interior part of the cell membrane. So they can't really pass through. Same goes for potassium. Again, has a positive charge on it. That charge makes it hydrophilic, and any hydrophilic substance won't pass through the cell membrane that easily. Now, but the thing is, our cells need sodium, right? They need potassium. They need sodium and potassium to work. So if they can't pass through the cell membrane like oxygen and carbon dioxide do, how are they going to make it through? This is where leakage channels come in. So we have a few leakage channels for specific ions that let them pass through. This right here, by the way, is an example of facilitated diffusion because as we can clearly see, the molecules are moving from an area of high concentration to an area of low concentration. But they're clearly being helped by these leakage channels. Hence the word facilitated because they're being helped by something.